Well, now that we have understood a few important issues in philosophy that concern the actual scientific activity, so we need to understand what scientists actually do. What scientists actually do. While we deal with this, you have to keep in mind whatever we have taught in the philosophy part, because the philosophical grounding actually dictates how we do science. And we have learned that during the Middle Ages, the main mode of thinking was believe, don't question. While in the Renaissance and the post-Renaissance period, the main mode of thinking that emerged was question, don't believe, have doubt about everything, test everything. So you notice that questioning is at the root of all science. Therefore, all scientific research starts with a question, always. All the time, a scientist is trying to find the answer to a question. And it is said that asking the right question is about 80% of a research work. So, one has to cultivate the faculty of asking proper right questions. The difficulty is that through your educative process, through school, through college, all the time the questioning mind is essentially suppressed. The natural questioning mind is suppressed. It is unfortunate, but it is a fact. So, while a child, 3-year-old, 4-year-old is always questioning the parents about everything around them, but as the child goes through school and college, the questions go down and they no longer ask questions, and this is detrimental to the health of science. So, while a student prepares himself for a career in science, one has to rejuvenate the faculty of asking questions. So, what I am trying to drive at is that all research starts from a question that the scientist has in mind, but all questions are not scientific. Therefore, one has to learn to distinguish between an unscientific question and a scientific question. Now, what qualifies a question to be scientific? The first point is that it should be a focused question. It should not be too vague, too general. It should be such a question whose answer can be sought by going through a systematic process. And the characteristic of vague questions, too general questions, is that you cannot conceive a possible research procedure by which you can get an answer. What is the meaning of everything? What is the meaning of life? How did everything come into being? These kind of questions are vague questions, too general questions, based on which you cannot do any scientific research. You can ask what is the origin of this, you can define the origin. What is the origin of that, you can define the origin. What is the origin of the moon, what is the origin of the sun, what is the origin of all that, you can define. But if somebody asks what is the origin of everything, well, everything, each one has a different origin, and therefore, what is the origin of everything is too vague, too general, and a meaningless question. So, that kind of questions we do not ask. So, it has to be questions that can be answered following well defined procedure. Okay. So, too vague, too general questions are not scientific. For example, idealists tend to ask this kind of too vague, too general questions and claim that they have the answer, while actually the answers are not really answers. Second is that in science, the science has built up a body of knowledge through the struggle of scientists over millennia, and we ask questions based on that, whatever we already know. So, we ask questions based on earlier knowledge, and then we seek answer to the new questions whose answer is not known to mankind. And therefore, the question has to be based on earlier knowledge. The question has to be based on earlier knowledge. We learn these through by reading books, by reading papers in journals, through sources on the internet, and so on and so forth. But whatever is known, you have a particular issue in mind, and on that you first have to learn whatever is already known, and then on that basis you have to ask a question. So, uninformed questions are not scientific. Uninformed means supposing something has already been done, but you do not know that it has already been done, you have that question, that would not be considered a scientific question, because already mankind knows the answer. So, you have to know what is already known to mankind by whatever means available, and only on that basis you have to ask a question which is whose answer is not known to mankind. That is a scientific question. The third issue one has to keep in mind is that science bases itself on materialism, as I said, and therefore the questions that we ask should be related to material processes and phenomena. But people harbor various types of beliefs and have questions regarding those beliefs. For example, miracles, for example, ghosts, for example, miraculous powers of stones or planets on our lives. So, these are unscientific beliefs that people often harbor, which are not related to material processes and phenomena, and those would not form the basis of any scientific question. So, the question should be regarding material processes and phenomena. So, in this, no personal beliefs should have any role to play. So, when a scientist asks a question, it is based on certain observations, certain things that happen, or earlier research has indicated that certain possibilities exist, and on that basis one can ask a question, but these are always related to material processes and phenomena. These are not any imaginary, imagined things. Whether or not mind power can bend spoons and things like that, people have all sorts of beliefs. Those are not subjects of investigation of science. And one should not say that science has not disproved these, no, because this science does not even care about this, doesn't even care about this, because it is only wastage of time. Science does not care about anything that is beyond material processes and phenomena. So, these are the three requirements of a question to be scientific. Now, what kind of questions do we ask? Let me, what kind of questions do we ask? The kind of questions we ask can be of how did it happen type. So, how did it happen? How did it happen type questions, for example, is how did the Himalayas form, or how did the moon come into being, and or how did the Indus Valley civilization come to an end. These are how did it happen kind of questions, and how did life originate on the earth. These are how did it happen kind of questions, and I will show that in answering questions of this type, how did it happen kind of questions, science follows a very well defined procedure of formulating hypothesis and then testing hypothesis and so on and so forth. I will come to that later. There are certain questions related to what is the value of a constant or a parameter. For example, the gravitational constant G in the Newtonian equation, force is equal to G m1 m2 by r square. Here the G is a constant, gravitational constant, and one may seek to find its value. One may also seek to find a value, for example, the distance between the sun and the earth. Say this is the earth, this is a parameter. So, G is a constant, R is a parameter, M1, M2 are parameters, and one may seek to find their values so that one can calculate the value of f. So, what is the value of a constant or a parameter in that constant's measurement? I will come to that later, but notice the question is of the what is the value kind. Okay. The third kind of question is the why type. Why does something happen? This is how did it happen, then, or let me complete the sentence. This kind of questions. For example, why is a leaf green? Why is the sky blue? Why do we see only one side of the moon, not the other side? Why does sugar dissolve in water, but sand does not? Why questions? Okay. So, so these are the kind of why questions that we often encounter, and we seek to give answer to the question. And so on and so forth. So, you notice that a question always starts with a how, what, when, why, this kind of questioning words, and always ends with a question mark. This is something I don't know why many PhD students miss. When you are asked anybody asks you what are you working on, And many PhD students say that I am working on solid state physics, I am working on the properties of this. No, you are always seeking the answer to a question. And therefore, when somebody asks what are you working on, you should state the question. This is the question whose answer I am seeking. And that should always start with what, how, when, which, that kind of word, and should always end with a question mark. So, remember, always a PhD student is seeking answer to a question, and your area of work is defined by the question you ask. So, whenever anybody asks you what are you working on, always state the question that you are seeking answer of. So, the question is very important, and this is how the questions are formed. There are various types of questions that we ask. Now, after you have asked questions, you notice that the questions can be also divided into a few types. I will delete this. The question can also be divided into a few types. There are a few questions, if you obtain the answer of that, the matter is closed, which means that the answer that you obtain does not prompt you to ask another question. For example, a question of the type of what is the value of the gravitational constant? You measure it, and after you have measured it, found its value, the matter is closed. Or at most you might say that we need to measure it up to more number of decimal places. Yes, you can, that is possible. More accuracy, that is possible, but not a fundamental question comes out of it. Such questions are called closed questions. Such questions are closed questions. So, what are closed questions? The questions whose answer does not lead to another question. The matter is closed. While there are also some questions, I mean, if you want to have other examples of closed questions, for example, what is the derivative of tan theta with respect to theta? You didn't know that, you learned that, and that closes the matter. What is the value of water, value of specific gravity of water at 30 degrees centigrade? You have a question, you measure it, and that closes the matter. So, there are how many eyes does a fly have? In the compound eyes are there. So, how many eyes are there? It is a question, a valid scientific question, you measure it, and that closes the matter. So, such questions are closed questions. And there are also certain questions whose answer, if you obtain those answers, that would open further questions. So, such questions, when you obtain the answer of that, it will lead to further questions. This is a very important issue in science. You need to understand that there are certain questions that are closed questions, there are certain questions that are open questions. And for example, let me give some examples of some open questions. Why is the sky blue? You open the answer, but that will again prompt you to ask further questions, because that answer opens up new questions. For example, how does the genetic information contained in our DNA result in creation of individual body parts? For example, my spleen, my eyes, how does it happen? This is a very intricate question, difficult question, and you might have that question in mind, but you notice that answer to that question cannot be obtained in just one go. There will be various small steps to obtain the answer to that question, and when the answer is obtained, that will open further questions. How does the stock market collapse in a particular country affect the economy of another country? A question, but an open question. Is there any dark matter that is invisible but still exerts gravitational influence on other bodies? An open question. So, similarly, there can be various open questions. And remember, when a scientist does his or her research, he or she always has an open question in mind. But the way to answer open question is that we divide that into a few closed questions and obtain answer to each closed questions individually. And that allows us to go forward towards getting an answer to that open question. So, when we have open questions, we break it up into a few closed questions. So, that is a standard procedure we take. That means, we have an open question in mind, we are working on that particular problem, but we break it up into smaller questions, each of which can be answered by a well defined procedure, and we ask maybe as researchers ourselves, we ask our PhD students to handle each closed question, and when one closed question is answered, we give them another closed question, and so on and so forth. The work of a PhD student often comprises obtaining answers to these closed questions, and through that ultimately it opens the gate for obtaining answer to the open question. The problem that often happens is that the PhD student gets to know only the closed questions, and therefore, they come out with an idea that these questions are all that are to be answered. No, the big picture is found by the open questions, and a PhD student should have a clear idea about what the open questions are, and how to break the open question up into a few closed questions and then obtain the answer to each closed questions. For example, suppose you are in the last century, when we did not know why the sky is blue, and you have that open question in mind, why is the sky blue? If you want to obtain the answer to that question straight, you will not be able to. So, you have to break it up into closed questions, like, is the sky more blue when you have more moisture in the air, or is it the same blue all the time? Does the blueness depend on the time of the day, or is it the same blue all the time? I am not talking about cloudy sky or dawn and dusk, I am not talking about that. The other times, is the same blue, or the blueness also changes depending on certain parameters. For example, the time of the day, for example, the position of the sun, for example, the amount of moisture in the air, the amount of things in the upper atmosphere, and so on and so forth. There are various things that can influence that. The moment you have formed these closed questions, you would find that each question can be answered. For example, does the blueness depend on the amount of moisture in the air? Suppose you have this question, it is a closed question, its answer is yes and no, and you can obtain the answer to that question simply by devising some way of measuring the blueness. It should not be that today I think it's very blue, today it's less blue. No, this is a personal perception which can be influenced by one's state of mind on that particular day. If you have fallen in love on that particular day, then the sky looks bluer. Therefore, you should not consider that as a yardstick. There has to be some kind of a measurable extent of blueness, the frequency of light that is coming and the frequency distribution and where the peak is, and so on and so forth. And then based on that, and you have to, there is a dependent variable, and the independent variable then would be the amount of atmosphere in the air, and every day you have to measure the atmosphere in the air and plot a graph. Today the atmosphere, the humidity was this much, and the blueness was this much. Another day the humidity was this much, the blueness was that much, and finally plot a graph and try to get some kind of a answer to that question. Is it dependent on the amount of moisture in the air? And when you have done that, the matter is closed. You know the answer. And that helps you to obtain the answer to the question, why is the sky blue? So basically you need to understand what does it depend on, and then you can properly answer the question, why is the sky blue? So what I am trying to drive at is that to obtain open question, you have to break it up into closed questions, but a student must have a clear idea about what the open question is and how it was broken down into the closed questions. And if at any point of time, a student is always working on a closed question, but there is at the back of the mind, the open question, which is the big picture, which forms the big picture. And it should be a closed question, should be a testable question whose answer can be obtained in a short span of time, following a very definite procedure, and so on and so forth.